So, hello everybody. My name is Uberto, and today we'll look at Quarkus and Kotlin, which are both very, very good technology, and we try to put them together. First, I will show some code, and if you have everything already set up on your machine, you can also type with me. But it's 50 minutes, so there is really no time to do a full workshop one-to-one and so on. But please stop me for any question. So this is what we are going to talk today. Show more than talk, I hope. So how many of you know about Quarkus? Perfect, just a couple of you. How many of you know about Kotlin? Okay, probably more than 50%. That's great. And how many of you are working on microservice, cloud native, or related technology? Probably 50%. That's very good, because I think you can find something useful in this session. As I say, any moment you have a question, just raise your hand and then I will repeat your question. It's a small room, so we don't need more than this. But let's start immediately. And what is Quarkus? Quarkus is it's kind of a toolset bring to us by Red Hat, but it's completely open source. And this idea of Quarkus is basically making very easy to work in a cloud environment. There is no new technology specifically in Quarkus. It's more like a way to make everything very easy to set up and to start. So, for example, everything that is Docker related is already included in the default. So you can, if you have something deployment or stuff like that, use a Docker. You have already all your script already prepared for you, so that you don't have to do much. And you can be productive from the first day. And then there are extensions, which are a way that Quarkus makes it possible to work with the existing framework. And they cover really a lot of frameworks. So probably any framework that we are using is already imported in Quarkus. If it's not, it's very easy to create a new extension. And also the other very nice thing is that unit testing are really first-class citizen. So differently from maybe other frameworks that make kind of hard doing unit testing your work. How many of you are using unit test at all? Yeah, almost more than half, I say. Unit test is very useful, and any kind of automatic testing. And they're really inside the Quarkus, so you can start using from the beginning. And it's also fully supports Kotlin, yeah, which is my favorite language. And so the first thing about Quarkus is that it's so easy to work with the cloud. The second thing is this developer mode, which is really awesome. I will show you. Basically means that you are typing and you can see your changes immediately without having to restart the application, which is make very easy to fast. And it also has a Uber jar set up already. So if you wanted to have your application deployed as a single jar, you can just have a one command. It's already done for you. So instead of passing a few hours looking inside the Gradle documentation or Maven, it's already prepared. And the third thing, which is usually the most hyped one, is about native compilation. So with Quarkus, they prepared everything to make it very easy to work with the graalvm substrate, which is a ahead-of-time compiler. So that means that your Java code will be compiled in native code completely. And you can package your application and deploy it in the cloud without the need the JVM, because it's completely native application. And it's not a Quarkus technology, it's something that you can do yourself, but Quarkus make it very easy because it's just a command. Build a native, and that's it. And you have the native compilation. Having said that, native has its own problem. Not problem, but let's say pros and cons. Because it gives you a very fast startup, and it doesn't need the JVM. But the compiler code is not faster than JVM code. I mean, people sometimes have the idea that if you compile everything ahead of time, it would be faster than normal JVM. That's not true, because the JVM is very good at optimizing code as it goes. The point is that it needs a bit of warm-up time, the JVM, to optimize all the code. If you compile everything ahead of time, you don't have to wait. So it's completely ready from the beginning. And you can see that is a cloud-specific thing, because if you have your big monolith that got released every 2 months, you don't have a problem if it waits a few seconds to be warm up. But if you have a kind of serverless architecture where you have to call your services every few seconds and they must be ready in a few milliseconds, that's a problem. That's why, for example, people left Java to use Go or stuff like that. Now, Quarkus native will give you that kind of performance. It has some limitation. It doesn't work on Windows, I think, still, for sure. It was only supporting Java 8 until a few months ago. Now there is a beta with Java 11, I think. It doesn't have the resources because it's not a jar, so if you needed to load some file, you needed to load from the file system. There is no class loading, and the reflection is kind of limited. But and it's also quite slow to compile, so it's not. But it's still very good. And if you are using Linux, I also suggest you to install SDK man, which is very useful too. So to be able to use Graal, you need to install the Java with the Graal inside, the graalvm, which is a compiler of Java written in Java. And the Kotlin, yeah, is the really fun language of JVM. And just to give you an idea, this is the Java code, how it got translated in Kotlin. Kotlin means really much less boilerplate, safer because nullable is inside the language. You don't need a special nullable annotation. And the extension function make it very easy to have a kind of DSL language. And this is not even, this is kind of normal. I mean, really, normal Java code that got compiled in more or less half of the lines in Kotlin. In some cases, much less because there are data classes that makes Java being in one line or stuff like that. But let's have a, how many of you know about the Fibonacci? Oh, well, probably. Well, in London, if you do an interview, usually they ask you Fibonacci and FizzBuzz, so you need to know them very well. And we try to do a Fibonacci. For those of you that doesn't know, Fibonacci is a sequence of number which create a very nice pattern. And the idea is that you start with 0 and 1, and then you add the last two. So 0 and 1 make 1, 1 and 1 make 2, 1 and 2 make 3, 2 and 3 make 5, 3 and 5 make 8. This is the sequence of Fibonacci. And if you draw it, make a nice spiral. That's enough talk. Any questions so far? Okay. I need to copy. Okay, so I need to copy this. Nice. And let's open a terminal. So basically, we are going to use Gradle, but the start plugin is only Maven for the moment. Another thing that I didn't tell you, Quarkus is still in beta, but they hope to release the version 1, official version this year, before end of this year. And it's been in beta. It's completely safe to use in production. It's completely stable. The problem is that they still changing the API. So if you start investing now on Quarkus, you may find that you have to change your scripting later. But there's not much more, and they said that they will freeze before the end of the year. So the current version is 27, which is just 1 week ago, and every 2 weeks there is a new version. We decided that what we wanted to create, a Fibonacci web. We decided the class, the extension, and you see that Kotlin is an extension, and REST Easy is another extension to make REST API easy to use. And we are specifying that we wanted to use Gradle as build tool. So we just run this one, and it will create a new project. So now we can go to our project, and we can do, we create a div wrapper for Gradle, just to make sure, and then we can say the one that we saw before. Quarkus dev. This is starting the dev mode. And you can see here a bit of a boilerplate, and then they say that basically Quarkus started in 0.7 second, listening on port 88. So if I go on port 88, I can see that Quarkus is deployed. And that's it. This is your application. And if we look at our actual class, it's just a class that I don't, probably you cannot read, but just it's a hello. And now we can do in IntelliJ, we open the new project. I think that was. So sorry, IntelliJ got confused. Yeah. And you can see, let's see, in the presentation mode. And here. IntelliJ has a problem. Sorry, IntelliJ today. It got confused because I have a same project before, and okay, this time it got it correctly. So just to make sure, this is our project. And you can see that it's already created the main. So this is the source, And there is the Docker file. So if you need Docker, it's already there. Docker and with both with the native version and JVM version. And for the Kotlin, it created a class that we specified in the, basically this class that I specified here, it created. And okay, so we import in IntelliJ. And basically here you are saying that there is a servlet that is hello. And this is this one, basically. And if I want to say, okay, but now I wanted to emit HTML, and instead of, because this is Kotlin, we wanted to put HTML body H1 hello Devoxx China, and then basically we just created a very basic HTML page. And that's it, we go here. We don't even need to redeploy to do anything. Any change will be automatically. And if we look at the logs, we can say that it's basically change source file detected. So every time we do a get, a call, it will check if any file change. And it's recompiling and stopped in very 12 milliseconds. Swap the class and then restart it again in total time 100 milliseconds. So it's really hard to feel. You cannot really notice. And this is not done with some strange of a hack like they were doing in Play framework, if you ever used. This is completely done on a JVM nice compiler. So any change that you do at your code, you don't need to do anything. You can just automatically get a patch. So we wanted to do a new class called Fibonacci. Restlet, yeah. And we needed to add this, okay, a bit of a boilerplate here. This is this boilerplate that I'm putting here. It depends on the extension, because in this case we are using the REST easy extension, so we have this annotation for path. If you use the other extension with other framework, it could be slightly different, but the general idea is the same anyway. And the class will be called Fibonacci Restlet. So let's call Fib. Let's call Fib here, a bit of. So basically, we are designing another entry point called Fib that will produce XML, and then we want also to give a number. So we said that this is an X that will be in the path. And then here we needed to add the there is an extension here too. Well, let's start first with the we can just say we can copy the XML here, the HTML here. And we want to say that Fibonacci number is, and then we can say something like, to put a number in Kotlin, you need to use $, and it will expand directly into string. So Fibonacci of x. And we can just define Fibonacci as a function. That to take an x of the type long, and we return another long. And as the first implementation, we can say that it's 42, and that's it. And now I needed to add and if I try to, so this is still running, this is hello, but if I try to do, if I put something that is nothing, it will help him and say which are the routes that are defined. And okay, now it's not working because it will say that basically it doesn't know how to get this number, basically, of content type. So I needed to tell him that this x basically is this x. There is a parameter name x. It's not parameter name, it's something like that. But okay, yeah. If we go here, yeah, we can say that it's returning 42. Question? Sorry. Any? Yeah? The repository? Yeah, I mean, you were asking for the repository of this source code. I will put everything on GitHub, so you can redo what you want. But yeah, it's very... And now, Fibonacci is not really working at the moment. It's clearly just a 42, but we can just say that basically the algorithm is when x, and then we can say if x is 0, we are long 0, we return 0. If x is 1, we return x. Elsewhere, we basically do the Fibonacci on x minus 1 plus Fibonacci x minus 2. And that's it. And basically now, if I do Fibonacci with 5, is 5. And 6 is 8. And 7 would be 5 plus 8. So 13. Sorry, 7. And 7 is 13. But if I try to put a very big number, it will be Stack Overflow error, because it's recursive. But we have a time, so we can show, okay, we can do a tail recursive Fibonacci. Because the problem is that every time it goes here, basically will go in the stack, and sometimes the stack will fill it. But if it's a tail recursive, basically, with the tail recursive, Kotlin will avoid this Stack Overflow. But the problem is that there must be tail recursive, and this is not tail recursive. So we needed to rewrite the Fibonacci in a tail recursive way. And we can just say tail fill. And to make it tail recursive, basically we needed to do only one call, yeah. And that means that we need the both parameter. So we need X, but we also need the current, and we need the previous. And at this point, we can move this stuff here. And then we say, OK, when X is, what we can say, when X is 1, we return the current, because we are going backwards. Otherwise, basically, we are going to call ourselves. X will be X minus 1. And then there will be basically, we wanted to say the current will be the current, the now current plus prev, the previous one. And the previous one will be the current, the now current. And then I need to put longer result. And now we can call basically tail fib passing X. Okay, for some reason, no. 1 and 0. And this is still okay, but it's working. So it's correct, but it's still not tail recursive. And we can put the tail recursive here. And this means that now I can do like this, and I get the result. And if we look at the actual code, this is another nice feature of Kotlin. That basically we can say, OK, this Kotlin code, how it will be, if I can convince IntelliJ, yes. OK, this Kotlin code, show me the bytecode. And basically, here it will show you the bytecode that it actually generated. And maybe you can say, OK, but I'm not so happy to read the bytecode like this. OK, so recompile this bytecode in Java. And so here you can say the Java code, Java-like code that he produced. And you can see that basically with this tail rec, it produces a while. There is no recursion anymore. It's completely reversed the recursion in a while. So it's actually, in Kotlin, is a bit intuitive because it's faster using tail rec than using the while yourself. Because, I mean, at least that's good, and sometimes it's better because if you go how to do the while better than yourself. So, but I mean, it's quite cool anyway. Be able to use a recursion because recursion makes much easier to read. And you can see that it's very fast. But the main point, of course, here was to give you the feeling that how nice it's been working with the Quarkus dev mode. You change the code immediately. You don't have to restart the server. You don't have to do anything. And if we start another terminal, of course it won't, but we can also do, it's a very, I don't know if you know autocannon, it's very, very simple performance. It's not really. We can do like this. Basically, it's just a very, very simple performance tool. It's definitely not something that you wanted to use in product. I mean, to check a real website, but it's quite nice because it gives you, it's bumping your application, and it gives you the latency, and the number of requests, and the number of requests per second, which is very slow. Because, of course, this is dev mode. So in dev mode, every time you call it, you have to check if the source are changed. So it's not as good. How do I change? Yeah. OK, we can stop Quarkus dev. And we can instead doing Quarkus build. We can create the Uberto that I don't remember exactly the command, but I wrote it somewhere. Yeah, Uberto is quite simple. Minus Uber. I think there is a slash. There is something. Okay. There is some problem probably with. Okay, I don't want it in this moment. I will show you later. Anyway, if you do the Uberto, you can easily make up the whole application and run from a jar. What I wanted to show you now is the dev mode. So basically, we just have to say build a native. And okay, now there is definitely a problem with. Could be that because also one thing that we haven't shown. Yeah, okay. The tests are failing. We changed the stuff, but there are also tests. And okay, the test is actually changing that the result is test. So if I run the test is failing. And it's also something nice that it gives you directly the web test. But for the moment, this is also a framework to test your REST application. For the moment, just ignore the test, which is not something that you should do, but in production. What's happened now? Okay, this is this. What's happening now? This was working perfectly 5 minutes ago. The usual demo effect. You can add the log. What's happening? Yeah, for some reason I cannot. Okay, no, I know, sorry. To make it able to use build native, they should improve the error message anyway. You needed to have a Graal configured. So I created a script. Basically, you need to have the graalvm available in the class path. And so I create a script to do to set up the Graal, which is very simple script, just to set up a graalvm to the current, must be Graal 19. So every time you do a build, it also try to do a build native. And you can see that the build native is taking time. It's definitely not fast as the normal JVM. It takes 1 minute and something, just for you to know. Questions? Okay, now there is also test for the native part, and then 1 minute, okay. And at this point, I can start, it's this Fibonacci web runner. And you can see that it started in 14 milliseconds. Instead of a normal Java application usually starts in 2 or 3 seconds. Quarkus they did a lot of work together with other frameworks like Spring Boot, Hibernate, or stuff like that to make able to start in Quarkus JVM in less than 1 second usually. But to go to 14 milliseconds, you really need to go native. And the final result is exactly the same. So there is no way to distinguish. But if we start the autocannon now, you will see that the number of requests is 10 times. And the latency is still basically 0. Because it's very, very quick to respond. And this is just to make sure. Is a 20 megabyte application. I don't know if you can read. Which is quite typical. If you use many framework, it can be slightly more, but it doesn't change so much. Because also Gradle is quite smart in trying to avoid to import the stuff from Java that doesn't need. But also to do something very small, like our application, you need also this REST API, you need a lot of libraries, so at the end it's quite big. But it's still 20 megabyte without the JVM. So you can put in the cloud without having a JVM, and it's still quite small. And then also the other thing is that there is the Docker file already. But if you want to go farther away, Kotlin also have something that is called Kotlin native. that basically compile directly to native without passing to the JVM. Now, just because the problem is that it's native code, so to open a socket, you need a, let me show you. To open a socket, you need to use C-level calls. And you cannot use any JVM library. So either you write yourself in Kotlin, or you bind a C library. It's very easy to bind a C library. You don't have a JNI in the middle, but it's still a C-level code. And I did something similar, just something that just return greeting from Kotlin native. And well, the difference is that, let's see, define. The Kotlin native executable the bug really is 300 kilobytes. So it's less than 1 megabyte. It's just, but of course, because here you don't have anything. So anything that you have to do manually. Any question? I mean, we have 8 minutes, so if you want question on the code, I can show you, or we can wrap up. Okay, let's. Okay, so so Kotlin native. Yeah, I created in GitHub if you wanted to play a bit with the Pico server. There is no JVM C bindings. Okay, these are a bit of the benchmark, which is really not a benchmark tool, but just to give you a fair idea on my laptop. Dev mode is 20K request and the few milliseconds of lagging. The prod mode with the Uberto is a 300K request in 10 seconds. So 30K requests per second. The latency is very good, and but of course the Uberto is a the Uberto is 10 megabyte, but also you need the whole JVM deployed. Quarkus native, more or less same speed, so there is really not a big difference. There is mostly no difference in speed between JVM and Quarkus native. The only thing that with the JVM mode you need a bit of warm up. You need a few thousand requests before you start. If you measure the first request, it will be quite slow, which may be a problem, because if you have a serverless application, that means that every time is the first request, so every time will be very slow. But in a normal, we are using a continuous deployment where I work. We deploy every hour. And for us, is we don't need the kind of performance of Quarkus native. The normal Quarkus is perfectly fine, but the dev mode make very nice to work with. Anyway, Quarkus native, I mean, very good, and the whole exercise, less than 20 megabyte. And Kotlin native is still have it says less requests per second because I just implemented with a single thread, because otherwise, I mean, it's more complicated. You have to do all yourself. And so it's more or less, probably if you have a native application, you wanted to spread many processes rather than having multiple threads. But anyway, you can also do multi-thread. So it totally is slow, but for a single thread, it's quite fast anyway. But the nice thing is that the XFI is very, very small. And also, comparing to C, using Kotlin native make very nice, the code is very nice, is memory safe, you don't lose pointers. Yeah, so at the end is your choice. Quarkus JVM, big memory, I mean relatively big memory, and relatively low startup. Dev mode, okay, is slow, but is very nice for development. Quarkus native is fast, and has very relatively small memory and a very fast startup time. And Kotlin native, I think it kind of makes sense only for kind of embedded. You can also cross-compile for Android or for Raspberry Pi or something like that. And of course, there is no JVM, but it's very, very small. So what do you think? I mean, you working on microservice? Or have someone tried the serverless? No, not yet. Yeah. But yeah, my suggestion is really to try Quarkus IO. It's a very nice framework. And at the end, if you use whatever you use, you are just producing normal Java code. I mean, it's not a new compiler. It just uses Graal or the normal JVM compiler. So the result is exactly the same that if you have coded without Quarkus. Quarkus only make the toolchain very nice to use. So, yep.
I have a question about this toolchain because actually it depends on which extensions you use.
Yes.
Sometimes completely different tools in your stack. And the question I've seen, for instance, Vertex, like,
yeah.
Was this actually really non-blocking application on top of Vertex? Because if it's not really non-blocking and I have to write in a non-blocking way, it's how can I check which actually, let's say, libraries out there? Does it really matter on that?
Yes, of course it matters because it's a kind of the other side of it's so easy to change extension that of course you can finish using some extension that you don't know much about or you don't realize what you are actually importing. And in this case we are using undertow with the Vertex because it's the default. To be honest, when I use myself Quarkus, I'm using a different extension with the HTTP4K, which is idiomatic Quarkus, and I don't want to use Vertex, basically. But you can use whatever you are used to, and of course you need to check, yes, which extension. I mean, there are extensions for Spring Boot, for undertow, for Vertex. And in this case, we are using it's well documented anyway in the website, what every extension will cover.
I would say that's, from my perspective as a developer, I really see it's fast, but I would like to see something like if I have this combination of extensions, my stack looks like this, like maybe some kind of a main and plugin that will report. You are having this, and this toolchain. Because I see this is very easy to switch to something else.
Yes.
And then you maybe
yes. The usual caveat will apply. You need to know what you are doing, definitely. It's the good part is that the Red Hat developers are really working very well with the community. So rather than having, for example, some specific Quarkus patch applied to several framework, they collaborate with the framework guy and they say, if you put this stuff, will be Quarkus happy. For example, they collaborate a lot with the Hibernate tool team, and they made Hibernate very happy to work with the Quarkus, and they made, at the end, it was faster to load also for non-Quarkus application, because they did a lot of contribution to Hibernate to make it faster to load. And if you wanted to check exactly what is in your extension, you have to look. Everything is open source, so you can look at the Quarkus website in the source code exactly which extension, what is importing. But yeah, it can be a lot, yes. It's so easy that you just change a line and it will be completely... Yes, it seems to behave the same because maybe you're using the same annotation for Java RS, and the implementation will probably be another talk. I mean, just the change in the extension will be completely different result with using the same code. My personally is not using much framework, so I'm trying to use Kotlin in idiomatic way with just libraries, and everything is a function from request to response. But everybody has its own problem. Yeah. Other question? Okay, I hope everything will be on GitHub. So if you go on my GitHub account, I will commit. I will also probably write a post about this specific exercise. Thank you for coming. Thank you.